Hi, it's Amber. In this video, we will explain everything related to scatter plots, how to create them in PowerPoint and Excel, as well as how to interpret them. You can click on the chapters of the video to see the segment you are most interested in. Let's start with explaining what a scatter plot is. A scatter plot is a two-dimensional graph that visualizes the relationship between two numeric variables by plotting data points as dots, where a single dot corresponds with a single data point. This makes it ideal for identifying correlations, patterns, and clusters in a dataset. The independent variable, the one being controlled, is typically on the x-axis, while the dependent variable, the one being tested, is on the y-axis. The relationship between these two variables indicates whether there is a positive, negative, or no correlation at all. We will discuss this topic more later in the video. Let's start by looking at some examples of scatter plots. Let's look at a scatter plot with a few data entries. As you can see on your screen, the scatter plots show the relationship between median household income, as seen on the x-axis, and life expectancy in years on the y-axis. The color of the dots indicate the region of the countries. As we can see when we plot the data, there is an apparent relationship with a positive linear correlation between median income and life expectancy, meaning that when income goes up, then life expectancy does as well. However, be careful in assuming that the correlation are linear or will remain linear if we plot more data points. If we add some poorer and richer nations, then we can clearly see that the relationship isn't linear, rather it follows a saturation curve. We can see life expectancy rise sharply at first when median income rise, however only to a certain amount, where after the curve flattens. Remember, this does not mean that there is a causal relationship between the two variables. A scatter plot just visualizes this perceived relationship and the correlation of the variables. Also, you can only interpret the results from the confined data you have. Never assume a true or universal relationship based solely on initial findings. Now let's turn to another example with a larger dataset. This scatter plot focuses on GPA scores of 100 students, where the x-axis indicates hours studied per week and the y-axis indicated their GPA score. If we add a trend line, the strong positive correlation between the two variables becomes more clear. It appears that the more hours studied, the higher the score. It could indicate a causal effect due to the strong correlation, but be careful with this assumption that a correlation equals causation. Remember, a scatter plot only visualizes relationship and does not prove causation. Now, let's try to make a scatter plot using Ampler. Make sure to follow the steps as they are similar even if you use an add-on or not. I will go over how to make a scatter plot in PowerPoint and Excel afterwards. To determine if a scatter plot is suitable for your data, ensure you have two continuous variables. And the aim is to analyze the pattern and relationship between them, how the independent variable x affects the dependent variable y. Also, make sure you check for clusters and outliers. Keep them if they aren't due to a measurement error, but be aware that they can significantly distort the pattern. To insert a scatter plot using Ampler, simply plot it in the following way. Click on the Ampler ribbon. Click on Ampler Charts. Choose XY, scatter plot, and insert in PowerPoint. To plot in your data, do the following. Double-click on the chart to open the data table. While the table is open, plot in the dataset. If you want to change a single data point, you can simply type it. After plotting in your data, it's time to customize your chart. Remember to rename the axes by changing the column headings. Also scale the axes to match the data values of your data. Resize the chart to fit the scale. You can add a third variable that can be categorical by using the Group section in the data table. Now let's finalize your chart. Make sure to only include necessary information. Add and tweak the following. Move the axis titles around. And scale the chart so all the data points can be seen clearly. Remember to resize the numbers on the axes and their titles. Then add a legend to explain the categorical variable. You can change the color of a category simply by changing the color of a dot. Then add a title to clarify the context of the chart. Finally, you can toggle on-off text labels. Make sure to scale them all down and move them around so the chart is readable. There you have it, a great scatter plot. To make a scatter plot in native PowerPoint is more tedious. However, it can be done, but with limitations. First, to insert in PowerPoint, click on the Insert tab and choose Chart. Under XY Scatter, choose Scatter and insert it. Then, open your Excel sheet and copy your data into the data table in PowerPoint. Add axis titles by clicking the plus icon and select it in the menu. Then add a chart title to clarify context. Remember to change color of the titles and axes as well as the font size. To scale axes, click on them and type in your desired scale. Also change the color and font size of these. Scale up the chart some more. Resize the dots by clicking on them. It's under Marker and Width in the Format Data Series pane. You can scale it up or down. If you want to add value labels, go to Add Chart Element under Chart Design and select desired position. What you see is the Y value. If you rather want to add a text, then you will have to write for every dot manually. To add dots in a group, you can normally format them. However, in our example, it won't work due to them having overlapping X and Y values. Otherwise, you need to split the data into multiple data series in Excel prior to inserting the chart, or you can color every dot into their associated group manually. There you have it, a scatter plot in PowerPoint. Now let's at last turn to how you make a scatter plot in Excel. You would have to do the following. Highlight the two numeric variables, then go to the Insert tab and then insert XY scatter. Scale the chart up to make the dots easier to see. To scale the axes, click on the axis and in the Format Axis pane, write the minimum and maximum bound. To add axis title, click on Chart Options and toggle on Axis Titles. Write the names. Now, let's scale the dots up a bit by clicking on them and change the marker size. To change color of the dots and add an additional variable, you can use conditional formatting or color them one by one. If you haven't split your data into separate data series before creating the chart, you would need to do it manually. If you want to label individual dots, click on Add a Chart Element and select Data Labels. Afterward, write the name. Color and write the name of every single dot. After having named and changed the color of every single dot, there is only a few steps left. Scale up the font of the axis. And add a trend line under the plus icon to highlight the direction of the relationship. Finally, add a chart title. Just like that, a scatter plot in Excel. When it comes to analyzing data using a scatter plot, there are some key things to look at. First, look at the overall pattern. Does the data follow a straight line or does it curve? What direction is the relationship? Is it positive or negative? Or is there no clear pattern at all? Are all the points close together or widely scattered? Is there any clusters? Are there points that don't fit the pattern, so-called outliers? What does this indicate about these data points? Why do they deviate from the main pattern? You can calculate the correlation coefficient to see the strength of a linear relationship. Let's look a bit deeper into some of these subjects. When analyzing scatter plots, clusters and outliers are especially important. Clusters are groups of data points that are very close in values. In this example, they are represented by the blue dots. Clusters indicate areas where data points group together, often revealing distinct subpopulations or special associations. Analyzing these clusters can provide valuable insights into common characteristics shared by these data points. On the other hand, outliers are data points that deviate significantly from the overall pattern. These are represented by the pink dots on your screen. Understanding what causes these outliers can uncover new insights within your data. However, be cautious. Outliers and clusters can skew or bias correlation coefficients and regression models, potentially leading to misleading conclusions. We've mentioned the correlation coefficient multiple times in this video, so let's dive a bit deeper. The Pearson correlation coefficient is a key concept in statistics, and it indicates the strength of a linear relationship between two variables from a scale from -1 to 1. A coefficient of 1 signifies a perfect positive correlation. This means that as one variable increases, the other variable also increases proportionally in the same direction. Visually, data points will lie perfectly on a straight line with a positive slope and no deviation from this trend. On the other end of the spectrum, a coefficient of 0 indicates no linear relationship whatsoever. There is no consistent pattern that allows you to predict the value of one variable on the other, resulting in a scattered random distribution of data points. There are 3 important things to keep in mind. Real-world data rarely produces coefficients of exactly 0, 1, or -1. Instead, values tend to fall somewhere in between, indicating varying degrees of correlation strength. A coefficient of -1 represents a perfect negative correlation, meaning the two variables move in opposite directions. As one variable increases, the other decreases proportionally. A coefficient of 0 does not necessarily mean there is no relationship at all. It simply indicates no linear relationship, but there could still be a nonlinear one. The relationship could, for instance, be more of a quadratic or exponential kind. But remember, the correlation only showed the direction and the strength of linear relationship and do not prove causality. To measure causality, you would use statistical methods like regression models, randomized controlled trials, or causal inference techniques. For outliers, look at, for example, variance, standard deviations, or z-scores. However, all these subjects are out of the scope of this video. Now that I have shown you different kinds of relationships and discussed correlation coefficients, let's turn to how you calculate one. Calculating the Pearson correlation coefficient is hard to do in hand, so let's make a simple example. You see on your left side a table with 4 data points. First step is to find the mean of x and y using this formula. After calculating the means, we get 5.25 for x and 6.5 for y. After this, we need to calculate the square deviations of x and y. Let's calculate. Here we get 3.3 and 3.7. Now it's time to find the correlation coefficient by adding up every data point. As we can see, the coefficient is close to 1, indicating a near-perfect positive correlation. If we put in the values on a scatter plot, it will be a near-perfect line. Calculating this can be hard with larger data sets. Thankfully, some calculators and statistical software like R can provide the number directly. You can add the number to your scatter plot in order to clarify how strong the linear correlation is. When creating scatter plots, there are some guidelines you can follow in order to showcase your data effectively and avoid pitfalls. Ensure that both variables are continues, meaning having numerical values as categorical data variables aren't suitable. Add a trend line to show the best fit for the correlation direction. Make sure to include axis labels and label key data points directly if it amplifies interpretation. Highlight clusters and outliers, for example, with color. Be aware outliers distort the correlation and regression models, and you may have to determine to remove extreme outliers. Use appropriate scaling for axes to capture the whole pattern. Like any other chart, there are some advantages and disadvantages of using a scatter. Let's start with when it's a good idea to use these charts. If you have a large data set with 2 continuous variables and you want to show the relationship between the variables, scatter plots are also great at highlighting outliers and clusters in the data. You should choose a different chart type if you have more than 2 variables. If you want to compare the values of data points directly, you need to visualize non-numeric variables, and if you want to show trends over time, While scatter plots are excellent for showing relationships between two continuous variables, they don't show the probability of getting a certain value or the distribution of values in a dataset. This is where a density plot comes in handy. A density plot is a smooth curve that shows how the data is distributed. It estimates the density of data values and is helpful for visualizing probabilities. They are beneficial to use instead of a scatter plot when you have too many data points and want to show the distribution of the data or the probability of getting a certain value. If we use our former example with 100 students and their GPA score, we can see that there is a high probability of getting a score between 1.6 and 3. On the other hand, there is a low probability of getting a score between 0.0 and 1.0. The histogram underneath highlights how many entries every single interval has. As you can see on the screen, the curve forms a positively skewed distribution, which indicates that the majority of students have a GPA above the median, and that lower scores have less probability than higher scores. Another alternative is the bubble chart, an extension of the scatter plot, which incorporates 3 variables instead of 2. This allows for the inclusion of an additional numeric variable. Instead of dots, the data points are bubbles, where the size of these correspond to the value of a third numeric variable. The bubbles add a third dimension to your data, allowing you to compare 3 pairwise relationships as well as the overall association between all 3 variables. To achieve the same with scatter plots, you would need multiple plots. If we revisit the previous example, comparing life expectancy and median income, and add the percentage of people with college degrees in each country, we can see that countries with higher life expectancy and income often have higher percentages of college degree holders. However, Italy and Germany are outliers. Although they have high life expectancy and income, they have a low percentage of people with college degrees. Additionally, you can color the bubbles by association, allowing you to add a 4th variable, which can be categorical. Here it indicates the region of countries. To summarize, scatter plots are a powerful chart, and a mainstay in statistics due to its ability to identify correlations, clusters, and outliers. Their simplicity is their strength, which allows for plotting thousands of data points, which other chart types can't possibly do without becoming unreadable. Further, the degree of linear association can be inferred, as well as if this association is positive or negative. At last, a scatter plot is a great start to visualize, examine, and analyze data, but you can't conclude there is any causality. To infer this, you would have to use statistical methods like regression models or other causal inference techniques. To get more insightful videos about everything PowerPoint and Excel, make sure to like and subscribe. You can get a free trial of Ampler by clicking the link in the description. See you in the next one.